I want to spend a little time talking about factorial. Factorial is often denoted with an exclamation point, and what it does is create a multiplication down to 1. Let me explain. So if I wrote 4 factorial, this means 4 times all of the whole numbers below it down to 1. So 4 times 3 times 2 times 1 is equal to 24. But then 5 factorial would be 5 times 4 times 3 times 2 times 1. Another way to think about this is that that is equal to 5 times 4 factorial. Since this right here represented 4 factorial, we would just say, oh, if I took 5 times 4 factorial, that would be the same as 5 factorial. And this is equal to 120. Factorial is a very powerful function. It grows really, really quickly. And oftentimes we're asked, like in calculus, to kind of rank functions and think about what functions are more powerful. Factorial is much more powerful than exponential functions. And an example I typically give is if I had n factorial, or I had something like 3 to the n. If I said, well, let's plug in 100. Well, in both of these cases, n factorial and 3 to the n, plugging in 100 would mean I had 100 numbers multiplied together. In this case, 3 to the 100th would have 100 3's written, all multiplied together. Enormous, huge number. But this would have 100 numbers multiplied together, 96 of which are larger than 3, since it'd go 100 times 99 times 98, and so on. Meaning, even though we've always been kind of conditioned in math classes to think exponential functions are so big and powerful, and they are, factorial is even bigger. So that's something to kind of recognize that it's a very, very powerful function. Now, we often use these to count things. For example, if I had 6 books on a shelf, how many orders could I have? Well, think about you've got 6 spots on your bookshelf. Well, you can put 6 books in the first spot, but once you put a book in that spot, there are only 5 books left to pick for the next spot, and then 4, and then 3, and then 2, and then 1, so 6 factorial, which is 720. Again, as I said, this grows really, really quickly. So it's a great way to do counting. Oftentimes we use it in probability to help us count outcomes. Another thing to know about probability is factorial is something that's kind of a weird situation, and that is 0 factorial. 0 factorial is 1. That always seems odd to people, but I want you to think about if I did 5 factorial divided by 4 factorial, that's just 5. If I did 3 factorial divided by 2 factorial, that's just 3. So if I do 1 factorial divided by 0 factorial, I have to get 1. And that ensures that 0 factorial has to be equal to 1 by algebraic manipulation. Another way I think about it is if I had 0 books to put on a shelf, how many ways could I order it? 1 way, I would leave the shelf empty. But remember, 0 factorial is 1. Now, the last thing I want to talk about with factorial deals with algebra. And I just want you to think, 5 factorial divided by 4 factorial. I already said that was 5, but I should just maybe write down the work that goes into that so that we can see why that's going to work, right? You can see 4 divided by 4, 3 divided by 3, 2 divided by 2, and 1 divided by 1. Those all divide out and leave us with 5. But also remember the top, 5 factorial, is the same as 5 times 4 factorial. And then those two divide out and lead us with 5. And this is a good thing to know how to kind of manipulate the algebra, because that way if I said I've got n plus 1 factorial divided by n factorial, well, n plus 1 factorial is the same as n plus 1 times all the stuff below it, so n factorial. So I divide out, and I'm just left with n plus 1. And of course, we could also do n factorial divided by the bigger one. And I'm going to change this just a little bit. Let's say we had n plus 2 factorial. So in this case, if we started with n plus 2, and then the number below it would be n plus 1, and then we'd hit n factorial. So you can see then we'd be left with 1 over n plus 2 times n plus 1. The other thing I'll always say is that you can always plug in some numbers into equations to just kind of get a sense of what's happening. So let's, for example, say that n was 10. If you say, well, 10 plus 1, so 11 factorial divided by 10 factorial is going to be 11. If this were, 10 factorial over 12 factorial, 10 divided by 12 factorial will end up being 1 over 12 times 11. So you can kind of plug in some numbers to kind of grasp what's happening. Factorial is an extremely powerful function, really useful in probability, but also extremely useful when we deal with series in Calculus 2. If this video helped you, please like and subscribe for more math help.